Here I briefly introduce you about my work on Wusi dataset. Wusi dataset is a brand new dataset specially designed for social motion prediction. It temporarily consists of 687 video clips of 2 to 32 seconds each at a frame rate of 25, involving 5 people passing the ball, stealing the ball, and blocking the ball, with a total video duration of 1 hour. For the poses and motion included, it not only has a full coverage of the body angle on upper body joints but also has a clear intention of each motion, since people recorded in the scene are playing real games with a clear distinction of winning and losing. In my previous experiments on MRT, existing datasets including CMU mocap and MuPulse 3D and etc. showed multiple drawbacks. Here I explain it with CMU mocap demos. For instance, there were only 1 to 3 people in the scene, which is obviously not enough to be described as a group. Moreover, we could see from the demo that there are not many interactions between people in the scene, while interaction in the context includes collaborations and competitions. Last but not least, we do not see global goals in motion. Here a global goal equals a purpose. Recently, in methods for motion analysis and motion generation, we take transformers and diffusion models as representatives. Spatial temporal correspondences are extracted explicitly. Thus, the problems that I addressed above are increasingly important now. Sadly, however, existing datasets could not offer enough or not even any solutions. I've been looking for solutions for the problems that I proposed, and that was when I put my eyes on competitive group sports. Well, first, 2 groups of people with multiple players are involved in the scene. Second, with a clear team division, the competitive relationship between teams is naturally formed. This guarantees the adversarial aspect of interactions. There will be offenders and defenders in the game. And interestingly, changeovers often take place due to the game nature, making the dataset more robust. For instance, actions after the defender blocked the ball will guide learning more naturally. Third, during the game, the 2 teams share the same global goal, which also gives the network a common learning purpose. Thus, the trained network can be generalized to antagonistic action generation and cooperative action generation, both smooth and realistic. Fourth, the dataset is made for group motion analysis and generation. Researchers do not need to further reorganize the data for related tasks. Well, thanks to the Laboratory of Computer Vision and Digital Art at Peking University, which provided the venue and camera array. Based on the calibration technique by Zhang Zhengyou, cameras were calibrated to prepare for a shooting schedule. Well, as mentioned above, I took basketball games as desirable sources. Restricted by the size of the court and the camera shooting angle, I turned the whole court basketball game into offensive and defensive practice in a small range. Well, the hardest part was data processing. Due to the limited camera resolution and lighting conditions, jittering and false positives happen all the time. Sometimes there are multiple candidates for basketball detection in a single frame, even after the non-max suppression. Here, random sample consensus is a great method for the model to kick out the outliers. With RANSAC, we could massively higher the detection accuracy due to the low camera resolution. Sometimes the estimation results are inconsistent and jitter. We reckon motions are continuous in the temporal view. Therefore, we try to denoise through sequential tracking. JDE Tracker was adopted to best meet our needs. We do tracking for both poses and the ball, yet we still need more refinements. False positives were showing up as outbursts. Thus, I managed to clean them through an efficient sliding window mechanism. Finally, to avoid excessive time differences between adjacent detections and estimation results, I adopted mean value interpolation and the 1 euro filter to generate smooth and realistic final motions in skeleton representations. Currently, I am adding more valuable annotations, including a passing sign to tell if there are ongoing passing moves, a passing discriminator to tell if the move is a fake motion or a real passing move, a block sign to tell if the defender has successfully blocked the ball, and the switch sign to tell the changeovers. Well, I'm planning to add more video clips to the dataset. Moreover, more motion genres will be added to the dataset with better lighting conditions and finer camera devices. The ultimate goal is to make full coverage of whole body joints. Briefly, my work on the Wusi dataset opens up a door for motion analysis and motion generation with social interactions, and it will contribute to generating smooth and realistic motions and poses. Thank you.